Welcome back, students. In this class we are going to discuss about the concept of inverters. It is a very important question for your external point of view. Now here, according to the syllabus, we are going to observe the inverters as Nmos inverter and various pull-up concept we have to discuss. That is a very important topic, and after that PMOS inverter, then CMOS inverter and BiCMOS inverter. Is it clear? Now we will discuss in this class the Nmos inverter. Okay, now we will look Nmos inverter. Now basically an inverter is a device which produces complement of input. That means the output voltage is the complement of input voltage. I hope that are you clear. Now you can observe the truth table of inverter. If the input is 0, the output is 1, and similarly if the input is 1, the output is 0. That's why inverter is a circuit which produces a complement of input. Is it clear? As output. Now if you look out, this is the first structure of an Nmos inverter, where if you observe that the pull-up device is a resistor and the pull-down device is enhancement mode Nmos transistor. Is it observed very clearly? Okay, and the source is connected to the pull-up device, and the source here is connected to VDD. That means the pull-up device is connected to VDD and the source of enhancement mode Nmos is connected to VSS. Now just look out the operation of this Nmos inverter here. Is it clear? Now you can very clearly observe when Vin is 0, what is happening here? When Vin is 0, if you observe that this enhancement mode Nmos transistor is in on off condition. Okay, now what is happening? Therefore there is a supply at the output voltage and the capacitor rises, that means charges. That means if you observe what is an output, 1 is an output. Is it clear? Now similarly if you observe that okay, when Vin is equals to 1, this condition Vin is equals to 1, what is happening here? Okay, now this transistor will be in on condition, then the capacitor starts to discharge. I hope that are you clear. Then V out is equals to what? 0. Is it understood? But the major issue, if you observe here, okay, what is the major issue? You can observe very clearly here. Okay, what is the major issue in no sense? When Vin is equals to 1 here, then there is a static path from VDD to VSS. You can observe the static current flow from VDD to VSS. Is it clear? Then you can observe very clearly one more time, when Vin is equals to 1, there is a path from VDD to VSS. Is it clear? Why? Because this enhancement mode Nmos transistor is in on condition. Therefore, there is a static current flow. This is the huge drawback present here. What is that? Static current flow is the drawback. And one more thing, if you observe that when the capacitor tries to discharge, okay, and one more time there is a supply here from VDD to V out. Why? Because this pull-up device is always in which condition? On condition. Is it understood? Therefore the output of the load capacitance never reaches to 0. That is the two drawbacks present here. If you observe the transfer characteristics of this, you can get a clear-cut idea. Now you can observe that this is the transfer characteristics of an inverter. Now if input is 0, the output is VDD. If input is 0, the output is VDD. When the input is VDD, you can observe that the output should reach to 0, but it is not reaching to 0. Why? Because you can observe that the capacitor doesn't discharge. Why? Because the resistor is a pull-up device, it is always in on condition. Is it clear? And these are the drawbacks present in the Nmos inverter of that type of structure. What is that? Output never reaches to 0. When Vin is equals to 1, okay, there is a path from VDD to VSS. There is a path from VDD to VSS, which leads to what? Static current flow. Okay, and one more very important drawback is even small values of resistor will occupy more area in the fabrication of process. Okay, now we will look one more Nmos inverter structure which tries to overcome these three drawbacks. Just we will look out that. Okay, this is one more structure of Nmos inverter where the pull-up device is depletion mode Nmos and the pull-down device is enhancement mode Nmos. Is it clear? Now you can observe that when Vin is equals to 0, okay, this enhancement mode will be turns on, then the capacitor charges to VDD. Okay, when Vin is equals to 1, then sorry for that, when Vin is equals to 0, this pull down device will be turns off, then this depletion mode NMOS is always in on condition, therefore the capacitor charges. And when Vin is equals to 1, you can observe very clearly that this transistor, because it is an enhancement mode transistor, will be turns on. Then what will happen? Then the capacitor discharges to 0. This is an ideal case, but if you look about the practical case, when Vin is equals to 1, okay, this enhancement mode NMOS transistor is in on condition and this depletion mode transistor is always in on condition. Therefore, okay, there is once again a path from VDD to VSS which leads to static current flow. Is it understood, all of you? Why? Because if you observe this shaded part here, this shaded part represents channel already present, therefore gate to source is going to be short. Even though gate to source consists of a 0 volts, this is always in on condition. That's why, okay, there is a path from VDD to VSS which leads to static current flow when Vin is equals to 1. But here the very important point, one more important point you have to read. Actually, ideally we are going to think that the capacitor is reaching 0, but what is happening, because this pull up device is always in on condition, okay, therefore the output never reaches to 0 when Vin is equals to 1. Okay, there is a static current flow, the output never reaches to 0. And what is an advantage of this circuitry if you observe that when compared to the previous? Absolutely, where the resistor is going to be used as a pull up device, but here what is going to be used as a pull up device? Depletion mode NMOS. Therefore, okay, less area is going to be required in the fabrication process. I hope that are you clear. That's it, guys. This is about Nmos inverter. After, okay, this we will discuss about various pull-ups. In this various pull-ups itself we will try to understand, but don't forget, still the drawbacks are continued in this Nmos inverter: static current flow and output never reaches to 0. We will see how these drawbacks are going to be overcome. Is it clear? Thank you very much. Have a nice day.